Embarking on the journey of econometric research is like navigating through a captivating flowchart, each step unveiling a new layer of insight. Let's break down the steps in this intricate dance of theory and data. Step 1. It's all about identifying the economic theory you want to put to the test. Picture this. You've got the Keynesian consumption function in mind. As income grows, people tend to boost their consumption, but not as much as the income increase. Step 1 of any economic analysis involves carefully selecting and identifying the economic theory that you wish to scrutinize or test. To illustrate this point, let's delve into the scenario where you have chosen the Keynesian consumption function as your focal point. In the realm of economic theories, the Keynesian consumption function holds a central position. It posits that as income experiences growth, individuals tend to increase their consumption, but this augmentation is not proportional to the rise in income. Imagine embarking on this analytical journey with the Keynesian consumption function as your guide. This theory, developed by the renowned economist John Maynard Keynes, sheds light on the intricate relationship between income and consumer spending. As you venture into this theoretical landscape, you are essentially exploring the nuances of how individuals allocate their additional income towards consumption while acknowledging that this increase may not be as substantial as the income surge itself. Your objective at this stage is to meticulously outline the premises and principles that underlie the Keynesian consumption function. This involves grasping the key tenets, such as the marginal propensity to consume (MPC), which signifies the proportion of additional income that individuals choose to spend rather than save. Additionally, understanding the concept of the autonomous consumption, which represents the baseline level of spending irrespective of income fluctuations, becomes pivotal. As you embark on this intellectual journey, consider envisioning hypothetical scenarios and real-world examples that align with the Keynesian consumption function. Visualize the economic agents, whether individuals or households, making decisions in response to changes in their income levels. Picture the dynamic interplay between income growth and consumption patterns, where individuals exhibit a propensity to amplify their spending but not at a 1-to-1 ratio with the increase in income. In essence, Step 1 serves as the foundation for your economic exploration, akin to selecting the right lens through which you will examine the intricate workings of the economic system. By honing in on the Keynesian consumption function, you are setting the stage for a comprehensive analysis that scrutinizes how individuals navigate the economic landscape, making choices that ripple through the broader fabric of the economy. This initial step is a crucial waypoint, guiding you toward a deeper understanding of economic dynamics and paving the way for subsequent stages of testing and validation. Now, let's move to Step 2: designing the mathematical model, where we express this theory in the language of equations and symbols. Consumption equals autonomous consumption plus induced consumption. In other words, consumption equals autonomous consumption plus marginal propensity to consume times disposable income. Here, the theory whispers that autonomous consumption is positive, and the marginal propensity to consume is a value between 0 and 1. Now, onto the canvas of Step 3, crafting our econometric model. We add a mysterious touch, a random disturbance term, to account for the unpredictability of human behavior, errors in measurement, and the shadows of omitted variables due to our limited knowledge. Now, let's discuss the desirable properties of an econometric model. These are like the qualities we want our model to have to ensure it's a good and reliable tool. 1. Theoretical plausibility. Our model should make sense in the world of economic theory. It should align with the fundamental ideas and principles of economics. Think of it as ensuring our model follows the rules of the economic game. 2. Explanatory ability. The model should be good at explaining what's happening in the real world. It should accurately describe and capture the behavior of economic variables. Imagine it as telling a story that matches the actual observations we see in the economic landscape. 3. Accuracy of parameter estimates. The estimates we get for the coefficients, those numbers we use in our model, should be accurate. They should come as close as possible to the true parameters of the structural model. We want them to be unbiased, consistent, and efficient, ensuring we're on the right track. 4. Forecasting ability. Our model should be a reliable crystal ball. It should be able to predict future values of the variables we're interested in. This is like making sure our model can guide us into the future with accurate forecasts. 5. Simplicity. Keep it simple. A good model represents economic relationships with the least complexity. The fewer equations and the simpler their mathematical form, the better, as long as it doesn't compromise other desirable properties. It's like saying, less is more, in the world of econometrics. Step 4 invites us to collect the appropriate data, whether it's cross-sectional, time series, pooled, or panel data. It's like setting the stage for our econometric masterpiece. First up, we have time series data. Picture this as a series of snapshots over time. It's like flipping through the pages of a book, observing how a variable changes at different moments. For instance, tracking the monthly unemployment rates or quarterly GDP figures, that's time series data in action. Such data allows us to track trends, detect patterns, and understand how variables evolve. But beware, it can be sensitive to outliers and might not capture the full picture if external factors significantly change. Now, shift your focus to cross-sectional data. This is like taking a snapshot at a specific moment, but you're looking at multiple entities simultaneously. Think of it as capturing a single frame of a bustling city, where each building represents a different entity, be it individuals, companies, or countries. For example, conducting a survey on income levels across various households in a city provides us with cross-sectional data. It's fantastic for comparing entities at a specific point in time, giving a snapshot of the present. However, it might miss out on capturing dynamic changes over time. Now, let's talk about pooled data. It's like having a buffet of information from various sources. Imagine gathering data on inflation rates from different countries and throwing them into a statistical pot. That mix is what we call pooled data, a rich blend of insights from diverse origins. It offers a broad perspective, utilizing data from diverse origins. However, be cautious. Pooling data can sometimes overlook individual characteristics, leading to a loss of specificity. But what if we want the best of both worlds? That's where panel data comes in. Imagine a movie. It's a combination of snapshots over time, like time series, and capturing multiple entities in each frame, like cross-sectional. So, if we're tracking the growth of individual firms annually over several years, that's our panel data right there. It allows us to analyze both individual and time effects, providing a comprehensive view. But, handling panel data can be complex, requiring advanced econometric techniques. In summary, each data type is a tool in your econometric toolbox, serving a unique purpose. Time series captures the rhythm of change, cross-sectional freezes a moment in time, panel data combines the two, and pooled data opens up a world of possibilities. So, which one should you choose? Well, that depends on the story you want to tell and the insights you're seeking. It's like choosing the right lens for your camera. Each type brings its own focus. As you embark on your econometric journey, consider the nature of your data, the questions you're asking, and choose the lens that best suits your analytical needs. In step 5, we take center stage, estimating our model using the most fitting method, like the seasoned performer using ordinary least squares or maximum likelihood, tailored to the nuances of our theory. In the 5th step of our economic analysis, we transition into the spotlight, ready to bring our chosen economic theory to life by estimating our model using a method that aligns seamlessly with the intricacies of our theoretical framework. Much like a seasoned performer selecting the perfect technique for a stellar act, we carefully choose between methodologies such as ordinary least squares, OLS, or maximum likelihood, tailoring our approach to the unique nuances of the theory we are testing. Picture this step as the moment when the theoretical constructs and hypotheses you've meticulously outlined in the earlier stages are translated into a mathematical model. The chosen estimation method becomes the stage on which your theory unfolds, revealing its predictive power and explanatory capabilities. If you opt for ordinary least squares, it's akin to choreographing a performance that minimizes the sum of squared differences between the observed and predicted values. OLS is a widely used and versatile method, particularly effective when the assumptions of linearity, independence, and homoscedasticity align with the characteristics of your data. Through this technique, you aim to find the coefficients that best fit your model, capturing the relationships between variables in a way that mirrors the essence of your chosen economic theory. On the other hand, selecting maximum likelihood estimation is comparable to crafting a performance where the parameters of your model are chosen to maximize the likelihood of observing the given data. This method is particularly powerful in scenarios where assumptions about the distribution of errors are less rigid. It allows for a more flexible approach, accommodating a broader range of statistical distributions that might better reflect the complexities of real-world economic phenomena. As you take center stage in Step 5, precision and attention to detail are paramount. The estimation process involves feeding your model with empirical data, allowing it to learn and adapt its parameters to best explain the observed patterns. This step is crucial for gauging the empirical validity of your theory, as the model's performance will be closely scrutinized against real-world data. Just as a skilled performer tailors their act to captivate the audience, you tailor your estimation method to captivate the essence of your economic theory. The goal is not just to fit the data but to unveil insights, uncover relationships, and provide empirical evidence that either supports or challenges the theoretical foundations you set out to explore. This step is the crescendo in your analytical symphony, where theory and data harmonize, creating a compelling narrative that contributes to the broader discourse within the field of economics. Now, let's gracefully transition to Step 6, where we meticulously scrutinize our model on 3 distinct fronts. This phase is akin to a thorough examination of our performance, ensuring that every element aligns with precision and purpose. The first front of scrutiny is economic validity, akin to meticulously checking if our findings resonate with the expectations set by economic theory. It's comparable to ensuring that the narrative we've woven aligns seamlessly with the plot we initially envisioned. In this stage, we delve into the economic underpinnings of our model, verifying if the estimated coefficients make logical sense in the context of our chosen theory. This involves assessing whether the relationships between variables align with theoretical expectations and if the overall structure of our model adheres to established economic principles. Moving to the second front, statistical criteria take center stage. Here, we subject our model to a battery of tests such as correlation coefficients, t-tests, and R2 tests, meticulously examining the statistical reliability of our estimates. Much like scrutinizing the performance of actors on stage, these statistical tests evaluate the robustness of our model. Correlation coefficients unveil the strength and direction of relationships between variables, t-tests assess the significance of individual coefficients, and R2 tests measure the proportion of variance explained by our model. These statistical criteria provide a quantitative lens through which we assess the credibility and precision of our model, ensuring that it stands up to rigorous statistical scrutiny. Finally, the third front of scrutiny involves econometric criteria, placing the spotlight on the assumptions that underpin our model. This is comparable to ensuring that our tools are not just performing but performing with grace, unbiased and consistent. Econometric criteria involves scrutinizing assumptions such as linearity, independence, homoscedasticity, and normality of errors. By subjecting our model to these criteria, we assess its reliability in the real-world theater of economic phenomena. This step ensures that our model isn't just a theoretical construct but a practical and reliable tool for understanding and predicting economic dynamics. In essence, Step 6 is the meticulous evaluation that follows the grand performance of model estimation. It involves cross-checking every facet of our model against economic theory, statistical rigor, and econometric principles. This multifaceted scrutiny ensures that our economic analysis is not just theoretically sound but also statistically and empirically robust, contributing substantively to the discourse in the field of economics. And now, as we reach the climax of our econometric journey, we arrive at the seventh step, forecasting. It's like having a crystal ball, but in the form of a meticulously crafted model that has passed the rigorous evaluation criteria. This step transforms our econometric masterpiece into a powerful policy tool, allowing us to peer into the future. Now, let's move on to the next stage, the seventh step, where our model, having passed through the trials of theoretical, statistical, and econometric scrutiny like a seasoned warrior, is ready to unleash its predictive power. This is the phase where our model transforms from a mere academic exercise into a practical tool with real-world implications. It's crucial to acknowledge that even if our model is economically meaningful and statistically and econometrically correct for the time period we used to estimate it, there's still a hurdle to clear. It might not be the best fit for forecasting due to various reasons. So, in this step, we dive into the stability of our estimates and how they respond to changes in the sample size. Imagine our model as a warrior preparing for battle. It has proven its skills, but now it needs to show it can handle different scenarios. We investigate whether our model's performance remains robust when faced with variations in the size of the sample. This is essential because the world is dynamic, and economic conditions change. We need to ensure that our model can adapt and provide reliable predictions beyond the specific time period we used to train it. In practical terms, this involves testing our model's extra sample performance. We're essentially throwing new data at it to see if it can accurately forecast economic trends outside the original dataset. It's like putting our warrior through additional challenges to make sure it doesn't just excel in the scenarios it's already familiar with but can also navigate uncharted territory successfully. So, in step 7, we're not just stopping at a well-built model, we're pushing it further to see if it stands up to the unpredictability of the real world. This stage ensures that our economic analysis isn't just confined to historical patterns but has the resilience and adaptability to offer meaningful insights for future economic scenarios. Now, let's talk about the final step, where we put our validated model into action for prediction and policy making. Think of it like this. Armed with our thoroughly scrutinized model, we step into the uncharted territory of the future, predicting economic trends, unraveling potential outcomes, and providing guidance for policy decisions. It's as if we now have a reliable compass to navigate the intricate terrain of upcoming scenarios. However, it's crucial to understand that forecasting isn't a crystal clear window into the future. Instead, it's more like a well-crafted map that aids us in navigating uncertainties. This tool equips policymakers, economists, and decision-makers with valuable insights derived from our econometric journey, helping them make informed choices based on a thorough understanding of the economic landscape. In this concluding stage, our model becomes a practical guide, offering a roadmap for decision-makers as they steer through the complexities of future economic situations. It's not about predicting the future with absolute certainty but about providing a reliable tool that enhances decision-making by considering the patterns and trends identified through our econometric exploration. As we conclude our introductory chapter, we have explored the intricate world of econometrics, decoding its definition, exploring its classifications, unraveling its goals, and dissecting the methodologies that breathe life into economic theories. As we close this chapter, remember that econometrics isn't just a toolbox of statistical techniques, it's a lens through which we view and understand the complexities of economic systems. Whether we're identifying theories, designing models, or forecasting the future, econometrics is our guide in this journey of discovery. So, until the next chapter unfolds, keep watching our previous videos. Thank you for joining me in this exploration of the first chapter of Econometrics 1. If you like the video, hit the subscribe button and share to your friends.